AC circuits part 1 series AC circuits series RL circuit series RL circuit resistor inductor R XL V is the input voltage source sinusoidal source C R series RLC circuit V is the sinusoidal voltage source R we can write this as JXL minus JX minus JX. Right, total impedance in the circuit Z is equal to R plus JXL. So Z is equal to magnitude of Z is equal to square root of R square plus XL square. Next, coming to the phase of the Z, phase of the impedance is equal to tan inverse of XL by R. Here in series RC circuit, Z is equal to R minus JXC. Magnitude of the Z is equal to square root of R square plus XC square. Angle of Z is equal to tan inverse of minus XC by R. Here Z is equal to R plus JXL minus JXC. From this, Z is equal to R plus, if we take J common, we get XL minus XC. Magnitude of Z is equal to square root of R square plus XL minus XC whole square. Coming to the angle of impedance is equal to tan inverse of XL minus XC by R. By R. Next, current in the circuit. This one is I. I current flows in the circuit. I. What is V? V is equal to Vm sin omega t. Vm sin omega t. V is equal to Vm sin omega t. Let current I is equal to V by Z. I is equal to V by Z. Here I is equal to Im sin omega t Im sin omega t minus phi sin omega t minus phi. I is equal to Im sin omega t plus phi Im sin omega t plus or minus phi. Plus or minus, why here it is plus or minus? If VL is greater than VC, we get minus phi. If VL is less than VC, we get plus phi. VR is equal to IR, IR, IR. Right. Voltage across the reactance element. Here this is the series RLC circuit. In series RL circuit, so voltage across the inductor is equal to I into XL. That means I is equal to J omega L. So VL is equal to I omega L at an angle of 90 degrees. Similarly, in series RC circuit, VC is equal to IXC is equal to I into 1 by j omega c. So VC is equal to I by omega c at an angle of 90 degrees. Here, here voltage across the inductor VL is equal to I omega L at an angle of 90 degrees. Here voltage across the capacitor is equal to I by omega C at an angle of minus 90 degrees. Okay. Now V is equal to V is the input voltage. Input AC voltage. Input AC voltage. V is equal to square root of VR square plus VL square. Here also V is equal to square root of VR square plus this one is VR plus VC square. Here if VL is greater than VC or VC greater than VC. Here we have two conditions, two cases. First one is VL greater than VC, second one is VC greater than VL. VL. If VL is greater than VC, V is equal to square root of VR square plus VL minus VC whole square. In this case, V is equal to square root of VR square plus VC square minus VL. Coming to the phasor diagrams, here I am taking I is the reference. Here I am taking I is the reference one. So if we take what is VL? VL is equal to I omega L at an angle of 90 degrees. If we take I as the reference, this one is I phasor, and here we have taken I as the reference, and with this reference current VL is 90 degrees leading. 90 degrees leading. 90 degrees leading. This one is I, this one is VL. VL. VL, there is a 90 degrees phase difference. Voltage is leading. Voltage is leading. VL voltage is leading. Or we can say current lags the voltage, or we can say that current lags the voltage VL by 90 degrees. 90 degrees. Similarly, here also we are taking I as the reference, and here we get minus 90. Minus 90. Here we are taking I as the reference, so VC is equal to I by omega C at an angle of minus 90. Here we are taking I as the reference, so with respect to reference current, this voltage across the capacitor is lags 90 degrees. Lags means minus. Here it has minus, so it lags. Here in series RL circuit, the phase is positive, that means it is leading. Here we have minus, so it lags. It lags 90 degrees. So VC lags 90 degrees. Here current is the leading one. Here current is current is leading. Current is leading 90 degrees leading. 90 degrees leading. Next, here if we assume if we assume VL is greater than VC, VC greater than VL. The phasor diagram. Here also we are taking I as the reference. I as the reference. I as the reference. If VL is greater than VC, the vector becomes what? This one is VL minus VC, and there is a 90 degrees phase difference. And there is a 90 degrees phase difference between these two. Here also we are taking I as the reference one. Here VC minus VL, current is the leading one. Here voltage is the leading one. 90 degrees difference. Okay. Now if we connect these two phasors like this, if we connect these two phasors like this, we get triangle like this. This one is phi. This one is phi. And this one is phi here. Yes, this one is phi here. So power factor is equal to real power by apparent power. Real quantity by apparent quantity. Real power by apparent power. Simply we can say real power by apparent power. So cos phi is equal to, here cos phi is equal to VR by V. This one is V. This one is V. 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 Or this one is V. So cos phi is equal to, this one is VL, VR, V. Cos phi is equal to VR by V. Cos phi is equal to VR by V. And it has series, RL circuit has leading power factor. It has leading power factor. In series RC circuits, cos phi is equal to, here also VR by V, but it has lagging power factor. Here cos phi is equal to, here also VR by V, here also VR by V. If VL is greater than VC, it has leading lagging power factor. Lagging power factor. If VC is greater than VL, it has leading power factor. Cos phi is equal to VR by V. Lagging power factor, because current is lagging. Lagging power factor, leading power factor. Here also it is lagging power factor. Current is lagging, voltage is leading. Lagging power factor, here we have leading power factor. Leading power factor. Coming to the phi, phi is equal to, we can write phi from this triangle. From this triangle, phi is equal to tan inverse of, phi is equal to tan inverse of, tan phi is equal to sin by cos. Here sin means VR by VL. VR by VL. Similarly here phi is equal to tan inverse of VR by sin by cos, VR by VC. VR by VC. Sorry. Phi is equal to tan inverse of sin by cos. Sin means VL by VR. Here also VC by VR. Here phi is equal to tan inverse of VL minus VC by VR. Similarly, here phi is equal to tan inverse of VC minus VL by VR. VR. Thank you.